We have 5 objectives in this video. The first one is the introduction of the dual piston pump. Second, to get know more about the components of the pump. Third, to know the operational principle of the pump. Next, the application of the dual piston pump. Lastly, to know the advantage and disadvantage faced by dual piston pump.
The pump that we choose is dual piston pump, which obviously have 2 pistons and 2 pump chambers. It is more efficient way to provide a constant and almost pulse-free flow. The 2 flow profiles overlap each other, which reducing the pulsation downstream of the pump. And this is the schematic diagram of the dual piston pump. Moving on to the components of dual piston pumps. Firstly, we of course have the pistons. So what are pistons? The pistons are the primary moving parts of the pump, typically made of strong materials like steel or ceramic to withstand the pressure. And how do they work? The pistons move back and forth within the pump chamber. When the piston moves back, it creates a suction effect, drawing fluid into the chamber. When the piston moves forward, it pushes the fluid out of the chamber under pressure. So the role of pistons are responsible for pressurizing and moving the fluid. In a dual piston pump, the 2 pistons either work together for more power or alternate to provide a smoother flow. Next, we have pump chamber. The pump chamber is the enclosed space where the pistons operate. It is usually cylindrical and made of durable materials like stainless steel. When the fluid enters the chamber through the inlet valve, the piston moves back. But when the piston moves forward, it compresses the fluid, forcing it out through the outlet valve. Thus, their role is to ensure that the piston can effectively pressurize the fluid. Next is the check valve. What is check valve? It is a one-way valve that controls the flow of fluid. They consist of inlet valve and outlet valve. So how do they work? So when the piston moves back, the inlet valve opens and the outlet valve closes, allowing the fluid to enter. However, when the piston moves forward, the outlet valve opens and the inlet valve closes, directing the fluid out. Then the role of this valve is to ensure that the fluid moves in the correct direction and prevent backflow, maintaining efficiency and consistent operation. We also have motor and cam. Basically, motor is the power of the pump. Meanwhile, cam is the rotating component with a specific shape that transforms the motor's rational energy into reciprocating motion for the pistons. And how do they work? The motor spins the cam, which has an uneven shape of lobes. As the cam rotates, it pushes the pistons in and out of the chamber, creating a suction and compression cycles. Their role is to supply the energy and convert it into motion drive the pistons. Without the motor and cam, the pistons won't be able to move. And then we have pump seal. The pump seal is a sealing element which often made of rubber, plastic, or metal. It is placed around the pistons and other parts where there could be a fluid leakage. It works as a seal. The seal sits tightly around moving parts. It acts as a barrier to prevent fluid from escaping the pump chamber. Other than that, it also keeps contaminants like dust or air from entering the pump. The role is obvious, as I mentioned just now, where it helps to prevent leakage and also protects the pump to ensure that it operates cleanly and reliably. Last but not least, the drive mechanism. What is drive mechanism? It is a mechanical system that connects the motor and cam to the pistons. It usually includes components like crankshaft and connecting rods. Crankshaft helps to convert the cam's rational energy into reciprocating motions for the pistons. Meanwhile, connecting rods help to link the pistons to the crankshaft. So they work together by connecting rods and transfer the motion to the pistons. They are important because they ensure the coordinated movements of all parts.
Okay, so next we are moved to the third objective, which are the operational principle of dual piston pump. The first one is reciprocating motion. It refers to the back and forward movement of the piston within the pump. The pump operates using reciprocating motion, where the piston move back and forth within their respective cylinder. This motion is typically driven by a motor connected to a crankshaft. The second is intake stroke. During the intake stroke, one piston moves away from the cylinder head, creating a vacuum in each cylinder. This vacuum opens the inlet valve, allowing fluid to enter the cylinder. This process ensures that the cylinder is filled with the fluid. The third is compression stroke. In the compression stroke, the piston moves towards the cylinder head, compressing the fluid inside the cylinder. This action increases the pressure of the fluid. Also, it closes the inlet valve and opens the outlet valve, which pushing the fluid out of the cylinder and into the system. Okay, so next is dual action. Dual action means that the pump has two pistons working in the tandem. The two pistons operate 180 degrees out of the phase with each other. While one piston is in the intake stroke, the other is in the compression stroke. This ensures a continuous flow of fluid with minimal pulsation. After that, check valve is the one of the principles in the dual piston pump. Check valves are crucial components that control the direction of fluid flow. They allow fluid to enter the cylinder during the intake stroke and prevent backflow during the compression stroke. This valve ensures that the fluid moves in the desired direction through the pump. Lastly is a sealing mechanism. To ensure there is no leakage of fluid between the piston and the cylinder walls. The pump includes seal around the pistons and the pump chamber to prevent fluid leakage and maintain pressure. Thus, by following all these principles, it allows the dual piston pump to operate efficiently and provide a steady flow of fluid.
So next, we're gonna talk about the applications of the pump. First, we have the automotive industry, where most modern cars use a system called hydraulic power assisted steering, or we call it as HPAS, to make steering easier. But how is this system related to piston pump? So, a piston pump is a device that uses piston to move hydraulic fluid through a system, generating the pressure needed in these applications. In simple terms, the piston pump had provide the force needed to turn the wheels with less effort. Second one, we have water treatment supply. In water treatment, dual piston pumps are used to move water or chemical under high pressure for filtrations and purification process. For instance, we have water jet cutting. High pressure piston pumps are used in water jet cutting system to propel water at extremely high velocities that capable of cutting through metal, stone, and other material. Lastly, we have food and beverage industry. In this industry, piston commonly used to transfer highly viscous substance and fill products such as cream, sauce, or liquid. These pumps are essential for manufacturers who desire a hygienic, accurate transfer of their product to ensuring that product characteristics like texture and consistencies are maintained without compromise. So next, we're gonna look to advantage of using dual piston pump. First, we have high pressure capability, where these pumps have the capacity to achieve high pressure, making them ideal for applications that require intense force, such as I mentioned earlier is water jet cutting. Another one, we have versatility with fluid. Piston dual pump can handle a wide variety of fluids, from low viscosity such as water and oil to more viscous fluid like chemicals and food products. This makes them suitable for use in diverse industries, from manufacturing to food processing. The last one, we have precise control. The design of piston pump allows for precise control over flow rate and pressure, which is crucial in applications that require accuracies and consistencies, such as in automotive power steering system. So, in previous slide, we already talked about advantage. Right now, we're gonna look to disadvantage using dual piston pump. First, we have cost and maintenance. Piston pumps can have higher initial costs compared to other type of pumps like gear or vane pumps. Their complex designs also means maintenance is costly because it requires special knowledge. The second one, we have sensitivity to contaminations. Piston pump can be sensitive to contaminations. Why? Because particles in the fluid can cause damage to the tight tolerance within the pump, leading to leaks and decreased efficiency. The last one, we have size and weight. Due to their robust constructions, piston pump can be larger, heavier than other pumps with similar output, which might be limiting factor in application with space or weight constraints.